Hello everyone, hope you are doing well. In my previous video, I built a basic AI agent. That agent was able to take input, process it, and give responses using an LLM, right? But there was one limitation. It could only answer based on its own knowledge. It doesn't know anything about our custom data, documents, or real time information. So, if we ask something specific to our data, it may either give a wrong answer or a simply guess. Now, the question is, what if we want AI to answer based on our own data, for example, like PDFs or documents or any company knowledge? That's exactly what we are going to solve in this video using something called Retrieval Augmented Generation, also known as RAG. In this video, I will explain the concept in a very simple way and then we will implement it step by step using Python. Let's first understand the problem. Have you ever asked an AI something and felt like the answer sounds correct, but you are not fully confident if it is actually right? That happens because the AI is answering based on what it already knows, not based on the real data. Here, what is happening behind the scenes? User asks a question, AI processes it and immediately generates an answer. But notice one thing, there is no validation step. It doesn't check any document, it doesn't verify any source. That's why sometimes it gives very confident but incorrect answers. This is called hallucination. So, now the question is, how do we make AI more reliable? What if we change the process a little? Instead of answering immediately, what if we make the AI search first and then answer? That is exactly what RAG does. Retrieval Augmented Generation. Retrieve first, generate next. Now, the answer is not coming from the memory, it is coming from the actual data. Let's make this even more relatable. Think about how you answer the questions. If someone asks you something important, you do not just guess. You check, search, and you confirm, and then you answer. That's exactly what we are making AI do. Now let's see how this works internally. We start with a large document, but searching the whole document is inefficient. So what we do, we break it into smaller chunks. This makes searching faster and more precise. Now here comes the most important concept, embeddings. Let me ask you something again. How does a computer understand a meaning? The truth is, it doesn't understand text like we do. For us, words have meaning, but for computer, it's just the characters. So, if you search AI, it may not understand artificial intelligence. That is a problem. So, we solve it like this. We convert the text into the numbers. These numbers capture meaning and we call them as embeddings. Now something powerful happens. Similar meanings have similar numbers. So instead of comparing the words, we are comparing the meaning. These embeddings are stored as vectors. What is a vector? A vector is a simple list of numbers. You can think of it like a coordinate in space. Closure vectors mean similar meaning. Now we need a system that can search these vectors efficiently. That's where the vector database comes in. Unlike normal databases, it doesn't search the exact words. It searches for similarity in meaning. This is called a semantic search. Now Let's bring everything together. First, we take the document, split it into the chunks, convert them into the embeddings, and store them as vectors. This is how we prepare our data. Now, when a user asks a question, we convert the question into an embedding. Then we search for similar vectors. We retrieve the most relevant chunks. And finally, we pass that context to the AI model. Now, the AI generates the answer based on the data. So, now the AI is not guessing anymore. It is answering based on the actual data. Now that we understand this clearly, let's see how we implement this step by step in Python. Now that we understand the concept, let's see how we implement this in the code. To save time, I have already written the code and I will walk you through step by step. First, we import the required libraries like FAISS, which means Facebook AI Similarity Search, which is used for the vector search, NumPy for handling the vectors, .env for loading the environment variables, and OpenAI for embeddings and the responses. Here, we also define the configuration values like data file path and the models what we are going to use, the chunk size and the overlap, and how many results we want. Now let's see how we process the data. This function splits the document into the smaller chunks. We are splitting based on the character length, around 2 characters per chunk. We take a portion of the text from the start to end and create the chunks. Then we move forward, but not completely. We use overlap. This overlap ensures that the context is not lost between the chunks. For example, if one chunk ends in middle of the sentence, the next chunk still contains that part. Now, once we have the chunks, the next step is to convert them into embeddings. Here, we convert the text into the embeddings using the OpenAI. Each chunk becomes a vector, which is the numerical representation of meaning. So, instead of working with the text, we are now working with meaning. Then we create FAISS index and store all those vectors. This FAISS acts as a vector database and helps us perform the similarity search. Now let's see how we retrieve the relevant data. This function handles the retrieval, which is the core of RAG. First, we convert the user query into embedding. Then we search in FAISS for the similar vectors. This is where the matching based on meaning happens. Using the results, we retrieve the most relevant text chunks. Now, let's see how everything comes together in execution. Now everything comes together here. First, we load the API key. We are using the same API key from the previous project. Then we load our custom data. Let me show you the custom data what I am using. So these are some lines that I have created in the custom data. We take a user input, then we execute the full pipeline, split, embed, and the store. Let me go to the actual code. Next, we retrieve the relevant context based on the query. Finally, we pass the context and question to the AI model, and the model generates the answer based on our data. This model will generate the response based on our data. So this entire code follows the same pipeline we saw earlier, like we split, embed, store, search, retrieve, and generate. Now that we have understood the complete flow and code, let's run this and see how it works in real time. Let me execute the script. Now the system is asking for input. Let me ask a basic question. What is RAG? Here you can see the system is not answering randomly. It first retrieves the relevant data from our document and then generates the answer based on that data. So the response is grounded in our custom data. Now let me try another question. What is AI? See, even though the wording is different, it still finds the relevant information. Let me show you the text file what I have given the data here. I have given artificial intelligence is the simulation of the human intelligence by machines. But while asking the question, I have asked like what is AI, but still it was able to provide me the correct answer, like artificial intelligence is the simulation of the human intelligence by machines. This is because we are matching based on the meaning, not the exact words. Now let me ask something that is not present in our data. What is blockchain? Here the system either says it doesn't know or gives no proper answer. This is the expected behavior because we have instructed the model to answer only from the provided context. So it avoids the hallucination. So this clearly shows that our system is not guessing answers. It is retrieving the data first and then generating the responses based on the data. And this is the core idea of the RAG. So in this video we built a complete RAG system from scratch. We started by understanding the problem with traditional AI, where model can sometimes give incorrect or hallucinated answers. Then we saw how RAG solves this by retrieving the relevant data first and then generating the response. We understood the key concepts like text splitting, embeddings, vectors, and vector databases like FAISS, which means the Facebook AI Similarity search. After that, we implemented the entire pipeline in Python step by step. We took our custom data, split it into the chunks, convert it into the embeddings, store it in FAISS, and then used similarity search to retrieve the relevant information. Finally, we passed that context to the AI model to generate accurate answers. And in the demo, we clearly saw that the system is not guessing answers anymore. It is retrieving the data and generating the responses based on that data. So the key takeaway is, instead of relying only on model, we can make AI systems more reliable by grounding them in real data. This is the foundation for building real world AI applications like chatbots, enterprise search systems, and knowledge assistants. Thank you for watching.